What's up, chat? Welcome back to another episode of Behind the Scenes with Mr. Shepard. Today, we're going to be doing an experiment to see if something bends even if we touch it just a tiny bit. Did it bend? I don't know. We're going to have to use math to find out. In order to do that, we got to collect some data. So here we go. All right, I got these two things, right? I'm going to take my object, which is a popsicle stick, okay? I'm going to put it right there. I want it to stay still, so I'm going to tape it in with some tape on both sides. Next, I'm going to write that object on my sheet of paper. Popsicle stick, okay? Can you see that? I hope so, because I can't see my computer screen very well. All right. If we want to find out how much this is changing, how much it's deforming, first we have to figure out where it starts. We're going to do that with a ruler in centimeters. All right, so I'm going to measure this here, and my popsicle stick is starting at 13 and a half centimeters, just about 13 and a half centimeters. I'm going to write 13.5 here. I'm writing it twice, okay? So this first column here, every time we make a measurement, we're going to measure where we're starting from so we know how much it changes. This is the first one with 0 force. That's why it's all written in. Now we're going to try 1 Newton of force. How do we know exactly how much 1 Newton of force is? Spring scale. Booyah. All right, so if you look at this, it's got numbers on it. It's got a side that says G for grams. Don't look at that. Flip it around. N for newtons, okay? Like Isaac Newton. It's a measure of force. How much force something is being put on, applied. Words are hard. Anyways, if you look at this, you notice that lip, it's right around the 0 there. That means we're starting at 0 newtons. That's what we want. If it's not at 0 on your scale, you need to twist this white knob till the lip is at 0 when you're holding it this direction. Okay, now for the fun part. I want exactly 1 Newton of force. So I'm going to press on this till I get to this 1 right here. All right, that's 1 Newton. Now I'm going to make another measurement, and it's at 13 centimeters. It deformed, it changed. It changed to 13 centimeters. I wrote that right there, 13, okay? We'll worry about these other parts later. Let's just record our data for now. All right. Next, is it still starting at 13.5? Yeah, it's still there. Okay, so in this category that says E, I'm gonna write, yeah, it returned to its original shape. It didn't break, it didn't permanently deform. It went back to where it started. Now, I'm going to look at my sheet. It says 2. I'm going to try 2 newtons of force. Let's see what happens. Still about 13 centimeters. It's not what I would have expected. So we started at 13.5 still. But this time, it deformed to 13 again. Did it return to its original shape? Yeah. All right, let's try 3 newtons of force. Oh, this thing's strong. Just 13 still. Did it return to its original shape? Yeah. Okay, so my data sheet looks like this. Now I'm not going to keep going, but in class you'll keep going. You'll keep adding more and more newtons of force until the object breaks, all right? Make sure to measure where it starts each time, because sometimes, as you're pressing, the object might change shape permanently. Okay,